All right, so we've completed the encoder. Now we need to start the decoder, JSON message decoder. And now we in this decoder we need to extend the byte to message decoder. All right, so we can just implement one method which is called decode. So first of all, in the decode, the first thing we need to check is if the byte buff, this one, byte buff. Now, if the readable bytes means all the bytes in this byte buff area, this memory block, if it's less than 5, we can return it. What does it mean? Now, remember our protocol. The first byte, it's the message type. The next 4 bytes, it's the length of the message. So if, the readable byte, if it's less than 5, then there's no meaning. We need to return. Now, there's something that I need to add on to this decoder. The byte to message decoder, they have some special feature. All right. So, what kind of feature is that? They have in Netty. Okay, when using the byte to message decoder, this one. If we return early from the decode, what do you mean by return early? Now this is returning early. Now, if you don't call it, here is in the param we have a list. So at the end we need to add the byte buff. Not the byte buff. We need to add the Java object into this list. Once we add something into this list, that means this decode method it's completed. And if we don't call this method, like say, if we return early from the decode method without producing a message, without adding anything to the list here, Netty will not discard the current buffer, which means the current buffer, the byte buffer, is not discarded. Instead, it automatically buffers the unread bytes. So this buffer is preserved. Okay? And when the next chunk of data arrives, it merges the new data with the previous leftover bytes. Okay, so if we are not put anything into the list and simply return it, and we say that with this early return, and then this byte buffer, everything in this byte buffer will be preserved. It's not discarded, and this byte buffer, it's waiting for the next chunk of data to arrive, and Netty is going to fuse them together, which means the new data, it's fused and merged with the previous leftover bytes, and then it calls the decode again. Right? So this decode method is read again and again until all the chunks merged back to the intact message. Alright, so once we call it returned, that means this byte buff is waiting for the next chunk to come. Alright, so let's see. So if it's the readable bytes is greater than 5, now we need to do something. Byte buff. Then we need to mark the reader index. So what's the reader index? I'll tell you in the next line of code. Now we mark the reader index, and the next step is we need to read 1 byte. The first byte, read 1 byte from this memory block. So this is the message type, right? Because this is the first byte. So let's see when we call this read byte method. Let's see what happened. Let's say we have abstract byte buff. Now, whenever I call this read byte, this is called reader index. The reader index is increased by 1. So this reader index is simply now we have 2 indexes, the reader index and the writer index. So we have 2 indexes whenever the content is read. The reader index is increased. Okay, so this reader index is the location. It's like a pointer. Okay, the pointer to mark down the current read location, the read position. Okay, they mark down the current read position, and the writer index is marking down the current write position. All right, we get the message, and then we get the byte buff. We read the next int, because the next int is the next 4 bytes, so that's the length. So let's look at that when we read the int, what's going on. When we read the int, when we call the read int method, the reader index is increased by 4. All right. Now we get the length. Okay, so we need to check, and then we need to check if the remaining byte. How can I find out the remaining byte? Byte buff, we can call a readable bytes, because the reader index is already moved, increased by 5. So the readable bytes, it's the bytes of the readable bytes is remaining bytes. So if it's less than the length, we need to return. We need to return because it's not a complete message. It's just a chunk. Okay, but before we return, we need to reset the reader index, and that's why I call mark reader index here. Mark reader index, it's remember marking down the current reader index. And when we reset the reader index, when we call this method, the index is going to reset the reader index to the location where you call this method. All right. So that's why we need to marking it down. Otherwise, if the next chunk comes in and you don't resume the reader index back to whenever it was before, then you fail to read the complete message. There's a problem. There's a bug. Okay? Okay, now next one, if we come into here, which means this block is not entering, and then which means now the readable bytes is equal to the length. And then we need to new a byte array, and the size of the byte array is equal to the length of the message. And then what the byte buff, we need to read the bytes into this byte array. And now the byte array has all the bytes from the byte buff, and now we can convert it past object. We can convert these bytes to message payload. All right, so we can convert this back to the message payload, and then we can call this one, remember list.add, and then we add something into this list, and then this decode method ends. All right, if you don't call this, if you don't do something, put something into this list, this decode is not gonna be completely ended because this byte buff is still waiting. it's become like a buffer. Okay, but there's some more thing that we need to do, because inside the message payload, I remember that I defined a payload here. And right now, this payload, we have nothing in the payload, because this method, the pass object method, once this object is passed, and the payload cannot be passed because this is an object and we don't know what payload it is for this object from when we pass the information from JSON format. So we need to manually do it. So we need to check switch message type. Now the message type we get it is read from the first byte here. So if that's 1, I think 1 is the register, right? 1 is the register. Yeah. 1 is the register and heartbeat is 5. So if it's 1 or 5, the payload, message payload, set payload, we said no. We don't need the payload for the registration and the heartbeat. And then we break. Okay, if that's call and forward, and then we need to call and forward, it's 2 and 3. And then we need to the message payload dot get payload, and now is the JSON. Now since we don't give them the class type, so this is the JSON object. Because if the JSON cannot pass the object into the right class because we don't have the class information. So the only way that they can do is to pass it into a JSON object. And now what we can do is this payload, because it's a JSON object, and then we can convert it to Java object, and then we give them the class. What kind of Java object you want to convert it to, which is the RPC request. Now, it gets back into the RPC request. The last step is we need to set the message payload, set the payload now to RPC request. Remember to break. Okay, the last one is 4, which is a response. So we can copy this, copy that, and we change this to response payload. And the response payload should be converted to response, RPC response. Okay, so we have the, here is a get payload object. Here, RPC response. And then we set the RPC response to the payload. That's done. So JSON object, so using a JSON to deal with this is not a wise decision. And of course, we are going to upgrade this protocol or this kind of the message format at the end of the course. We are not using JSON. JSON is not a good way to transfer the message. Okay, we have a better way. All right, so we finished the JSON message decoder and encoder, and the next step is we need to configure these two decoders, these two handlers, into the server and the client.